Let's talk about Lance, a new open model from ByteDance. What makes it special is that it is a single, unified model. Instead of one tool for making pictures, another for editing them, and a third for video, Lance does all of it with one set of weights. And despite being only 3 billion parameters, it is small enough to run on a single consumer graphics card. In this short tour, I'll show you every mode it has, the real results I got, and exactly how fast it runs on one RTX 4090. So what is Lance, really? Think of it as one single brain rather than a pipeline of separate tools bolted together. That one model can do two opposite things. It can read and describe an image or a video, and it can create brand new ones from a text prompt. Crucially, it treats a still picture and a moving video as the same kind of problem, so the same weights handle both. And because it is only 3 billion parameters, the whole thing fits comfortably on a 24 gigabyte gaming GPU, no data center required. Here is the idea without the math. Lance has an eye, a vision encoder borrowed from Qwen, that turns any image into tokens the model can reason about. It has a video codec, the WAN compressor, that squeezes frames down so the model can paint them back out. And in the middle sits one shared transformer that uses separate expert pathways for understanding versus generation, so the two skills don't fight each other. The clever part is that almost all of this was trained from scratch on a modest 120 GT8 GPU budget, which is tiny for a model this capable. Enough theory. Let's actually look at what comes out of it. I ran every single mode on my own machine, with my own prompts and photos, so everything you're about to see is real output from one RTX 4090. First, the most familiar mode, text to image. You give it a sentence, and it paints a picture. On the left is a rainbow fox from a long, detailed prompt. Notice it keeps every element straight without losing the thread. Lance is also unusually good at rendering actual readable text inside an image, which most models smear into gibberish. It swings from photorial, like this golden hour bookstore, to fully stylized without complaint. And on the 4090 each picture takes only about 10 seconds, so it feels interactive. Second mode, editing. Here I hand it a real photograph and just tell it, in plain English, what to change. On the top row it added round sunglasses and a Santa hat to my own portrait. And importantly, my face and pose stay the same. It only changed what I asked. On the bottom row, it took a friend's photo and restyled the entire image into a 3D Pixar-style cartoon while keeping him recognizable. This instruction-driven editing is where Lance is genuinely strong, and the benchmarks later will back that up. Third mode, subject-driven generation. Instead of editing the original photo, you give Lance one reference image of a person and ask for a completely new scene. Here I gave it my portrait and asked to be an astronaut in space. It built an entirely new image, the spacesuit, the Earth behind me, yet my face carries over faithfully. On the left is the reference I gave it. On the right is what it generated. With a single reference, this identity preservation works really well, and we'll see the limit of it shortly. Fourth, style transfer. And here's a useful lesson. The trick is to describe the style you want in words, rather than handing the model a style image to copy. When I simply said make it a flat comic cartoon, I got the clean line art on the left. When I said watercolor painting, I got the soft, dreamy version on the right. In both cases, the person stays recognizable, while the medium changes completely. Describing the style in text is the reliable path. Feeding it a reference picture of a style is the one thing that doesn't work, which I'll come back to at the end. The fifth mode flips everything around. Instead of making images, Lance reads them. You give it a picture and a question, and it answers in plain text. On the left, it correctly identified soldiers raising the Egyptian flag. It understood both the objects and the symbol. On the right, it actually read the text on the poster, real optical character recognition, not a guess. And this understanding mode is the cheapest of all, about 3 seconds per image, because it only produces words, not pixels. Now for the headline act. Text to video. This is the very same model, just generating motion instead of a still. On the left, a tropical coastline where the waves actually roll in and the palms sway. The movement is coherent, not flickery. On the right, a red panda surfing, keeping its balance on the board. These render at 848 by 480, 12 frames a second. And to be clear, the clips you're watching right now are the genuine output, generated on the same single 4090. The seventh mode edits an existing video. Top pair. I gave it the original clip on the left and asked to make the car red and put it on a snowy mountain road, and that's exactly what came back, with the motion preserved. Bottom pair. The woman keeps her natural movement while the entire background becomes a fairy tale castle at sunset. This is the most memory-hungry mode of all, because the model has to hold the original video and the new one in memory at once. So on a 4090 I run it at a slightly lower resolution, and we'll see why in the numbers. And to close the modes, video understanding, the moving picture version of reading an image, I fed it this short clip from a film and asked what's happening. It described an elderly man in a white head wrap with a solemn expression, sitting in a simple room with a wooden door and white curtains, accurate on the people, the clothing, and even the mood of the scene. The one thing it won't do is name a real person or title. It describes what it sees rather than recognizing who it is. So the results are good, but how good and how fast? Let's put numbers on it. First the official quality benchmarks, then the real speed and memory I measured on my own card. Here's the reason a 3 billion model is worth your attention. On Geneval, the standard image generation test, Lance scores 0.90, tying a model more than twice its size and beating the 20 billion Quen image. On VBench it edges out a 14 billion video model. And on the Gidit editing benchmark it clearly beats the larger Bajol and InternVL models. The gray bars are those bigger competitors. The purple bars are Lance. It only trails slightly on one prompt following test. For its size, that scoreboard is remarkable. Now my own measurements. This radar plots all 7 modes. The red shape is peak memory used, and the blue shape is time per example, each scaled to its own ceiling. Look at the geometry. Text to video is the one spoke that reaches the rim on both axes, the only truly heavy job. Every image mode collapses into a small inner cluster. Low memory, just seconds of compute. The practical takeaway falls right out of the shape. Image generation and editing feel interactive, while video generation is the one task you kick off and walk away from. The question everyone asks, how long a video can it make? The model is hard capped at 121 frames, about 10 seconds at 12 frames per second. The surprise is the red shape here. Peak memory barely moves as the clip gets longer, because the attention is efficient and the decoder works frame by frame. The green shape is the duration you actually reach, climbing to the full 10 seconds. The bottom line is that you can generate the entire 10-second clip at native 480 resolution on a single 4090. Dropping resolution only buys headroom you don't actually need. No honest review skips the weak spot. The one thing Lance cannot do is compose 2 reference images into a single result. Here I gave it 2 different people and asked for both in one shot, and the faces blended together into one look instead of staying distinct. The same failure happens if you combine a person with an object, or a photo with a separate style image. The reason is technical. The model places all the references at the same position, so they overlap. The rule of thumb is simple. Use a single reference image and describe everything else in words. If you want the full story, every result at full quality, the 2 small code fixes it took to fit on 24 gigabytes, and the exact commands to reproduce all of this, I've written it all up in a detailed article. The link is on screen, and you can scan the code to jump straight to it. Lance itself is open on GitHub and Hugging Face, so you can download the weights and try it yourself. That's Lance. One compact model reads both images and video, holding its own against systems many times its size, all on a single graphics card. Thanks for watching. This was summarized by Omar Hosni, and every picture and clip you saw was generated locally on one RTX 4090.